Welcome everybody to our February 2021 novice meeting. We have a wonderful presentation tonight by our novice chairperson, Debbie Moran, and she's going to talk about all things eclipses, occultations, grazes, things like that. So these are astronomical events that if you've never participated in one, and Debbie and I were just talking before we started here about the first time we participated in an occultation. They're absolutely fantastic, and there's a lot of really good science that goes along with these things as well. But without further ado, I'd like to pass the microphone over to Debbie. Debbie, I'll stop my share here and let you take control.
Okay. Well, thanks everybody. Welcome to the novice meeting for February. And my name is Debbie Moran. I'm the novice chair. I've been a member of the Houston Astronomical Society since 1980. And this particular subject is near and dear to my heart. One of my favorite things to do in the sky is just look at things that change. When you first look at the sky, you think everything looks very static. The stars don't really move appreciably in our lifetimes. But there's so many things you can look at with your telescope where you're perceiving motion. And we're going to discuss all those things. So I'm calling it things that go bump in the night just to be cute, but that is a misnomer. All of these things that appear to be coinciding in position in the sky are often very different distances and has nothing to do with going bump in the night. So I was inspired to do this topic by the December 21st conjunction of Saturn and Jupiter, and realized I hadn't spoken about this before. This is a beautiful image by Steve Fung, looks very much like what I saw in my telescope at the time. And it's the only time I've seen Saturn and Jupiter in the same field. And when one of these things comes up, be sure to take advantage of it. Often these are many years apart, or sometimes it's once or twice in a lifetime that you have these opportunities. So starting out, I wanted to give you some definitions. So the term apole simply means the closest approach of any two heavenly bodies, just in pure distances seen from Earth in the sky. Conjunction is a little bit more specific. It's more technically when the two bodies have the same right ascension or same ecliptic longitude. So the sky has coordinates, sort of like longitude and latitude lines on the Earth. And ecliptic longitude would be centered on the ecliptic, which is tilted 23 degrees to the celestial equator. So that's because the Earth's axis is tilted. So that's a different set of coordinates and really is very well relevant to the planets. And occultation is when one body passes in front of another to the point where it obscures it in view. So the body is actually large enough to cover the other thing that's behind it. A transit is when something much smaller passes in front of something much larger. So you will see it on top, you will see its image on top of what's behind it. An eclipse is when a shadow falls from one body to another. So in that case, you have to have three bodies lined up, the sun, and then the body casting the shadow, and then the body on which the shadow falls, and that's called a syzygy. And there's all of these types of things between many different types of objects. The other thing you must know if you ever want to observe these is how universal time works. So you will notice when these things are listed, they will give you a time with the term UT after that. That stands for universal time. That's a time zone at the meridian, which is arbitrarily chosen to go through Greenwich, England, where the Royal Greenwich Observatory is. And all of these events are listed in UT, and you must correct for your time zone. So Houston is in the central time zone. And during the winter, when we're in standard time, we are -6 hours from the universal time. And in the summer, when it's daylight saving time, which I hate, by the way, we are -5 hours. So that's a bad time for astronomers, daylight saving time. So you need to take all of those times and subtract that many hours to know what time something really is, and be sure to do that because something may end up being in the daytime for you that looked like it was nighttime. So I found an app today actually called inthesky.org with some details of some upcoming planetary conjunctions that are visible from Houston. I noticed that it took my phone's location, and when I clicked on each event, it told me specifically how it would be viewed in Houston. So I know during this year, there's a few instances where planets come very close to each other. At least two of them, which are observable from Houston, would be another instance of seeing them in the telescope eye field at the same time, meaning less than about a degree apart. So the first one is March 5th, when Jupiter and Mars will be visible before dawn. And there'll be 19 minutes of arc apart. So that's about a third of a degree. And remember, it's about 180 degrees from horizon to horizon. And it rises at 5:23 a.m. And then as soon as you can see it, it'll be visible until it's just lost in the dawn light. On March 29th, Venus and Mercury will be visible before sunset. So as soon as they're visible, you can observe them starting about 11 degrees up. That's not very far. That's about a fist at arm's length above the horizon. So you need to be sure you have no houses or trees in the way. And then they will set about 9:30 p.m. And those will be 24 minutes of arc apart. So for comparison, the full moon is about half a degree wide or about 30 minutes across. And most telescopes in their low power eyepiece can definitely see the whole full moon. So I'm going to start with one of my favorite things, which is one of the first things I did as a new astronomer in the Houston Astronomical Society. So when I first joined, there was a guy named Don Stockbauer who would get up at every meeting and talk about grazing occultations. And this is a situation where the edge of the moon, usually the dark edge, which is when you can observe them, is just grazing a star. So the star is going in and out behind the mountains. And then there's also asteroid occultations, which I've not been successful at yet. I've only tried one. But there is an organization called IOTA for short, or the International Occultation Timing Association, which makes all the predictions for these things, which I will show you a little bit later. This diagram on the left here shows you the kinds of information you can get. So for instance, for an asteroid occultation, you would have that, which means an asteroid passing in front of a star, you would have a lot of people lined up in different locations, and they would be watching that star blink out and then blink back in. And some of them would see that happen longer, and someone would see that happen a shorter time, and some would have a miss. And you actually need this miss data. When you put that all together, you actually get a profile of the asteroid, so that you're doing real science when you do these. So my favorite thing was the grazing occultations. It was easy to do in a small telescope. The stars were usually reasonably bright and easy to see against the dark edge of the moon. This just shows you a diagram of how these things work. So the moon is actually moving across the star. It appears like the star is coming at the moon and moving this way. And Aldebaran is a very bright star, so it's always considered a great thing if you get a very bright star to look at, because it's very impressive. What happens, some of the useful information that grazes give you is you can get a very detailed profile of the mountains on the moon at that edge, at that one location, because the people who are very positioned along the path where they see the star go very low, they may see one disappearance and one reappearance, but they don't see all of these peaks and valleys in the mountains. Someone higher up will see more peaks and valleys, and so on. Then someone's going to get just a really short disappearance for the last peak and a reappearance of the star, and someone else is going to get a miss. But you kind of need the miss to know where the ends of those peaks are. So I actually found a pretty good, I hope this will work, a pretty good video on YouTube. This star is faint, so I'm going to take my, I hope you guys are looking on large screens. I'm going to take my cursor and show you where it is to start with. And we're going to be watching it. Actually, I think this is just a screenshot. We'll be watching it travel from about here to here. And you'll get a feel of the intensity with which you watch these things, especially with a star that's not that bright, but you will clearly see it go in and out. Now people use video because we can get more accurate timing. So while you're watching these things, you're running an audio of the time with a special clock, which is ticking off the seconds and announcing universal time, so that you are timing when the star goes in and out, real time. We need to know not only how often that happens, but what time it is in order to coordinate all of these observations. I used to do these manually, so we would be instructed to use a single syllable like D for disappear and R for reappear. And so you can kind of think that mentally while you're watching the star progress. So I hope you guys can see this little white dot. Let me see if this thing's going to work. And it will come on. I tried this earlier and it took a minute to spool up here, I hope. Maybe. There we go. Okay, so here's the star. Blinked out there. This is a relatively long, this goes for about 25, 30 seconds, this disappearance. There it comes. So I think I hope that worked okay. I know sometimes videos are a little bit stop action, but I think with something like this, okay, I'm getting a thumbs up from or an okay from Bill Spitzeri. You've just done your first grazing occultation if you've never done one of these before. And this is quite doable in a small telescope. I just use a little 5-inch telescope at the time. And most of the stars, that was actually the faintest one I've seen. That star was only about 11th magnitude. So you would need a decent telescope, or it's not especially bright. Most of the stars are brighter than that. I did find this one just still photo of a graze of Jupiter and its moons, which I've never observed anything like that. But anyway, there's all sorts of cool things like that to look at in the sky. Now there's also asteroid occultations. This is when an asteroid passes in front of a star, and like I showed you at the beginning, it's useful for finding the shape of the asteroid. Some of them end up being potato shaped, and usually the larger ones are round, but this gives you an exact size and shape of the asteroid. And so again, you would have observers at different points where some of them will see the star will never get occulted at the top and the bottom of the asteroid. I'm looking at this little rock down here on the bottom left. And then others will see, depending on the shape of the asteroid, the star dim out for a much shorter time and others for a longer time. And then you can end up with a shape of that asteroid. So I also found an asteroid occultation video. And in the still picture, you don't see the star. You'll see it. I'm putting my cursor right now about where the star is going to be. And when I start the video, you will see the star. And you'll notice what happens to it. Right there. It winked out. I hope you saw that. it's actually going to brighten a little bit. So that's an asteroid occultation. And let me go to the next slide here. So anyway, you end up with the shape of the asteroid. This one, there we go. So this is another wonderful video, actually, of Jupiter occultation, the moon occulting Jupiter. And this is sped up 5 times, but even at 5 times slower, this is one of those times you can perceive motion in the sky. And for those of you who are not as familiar with it, you might notice that the moon appears to be undulating. That's what we call the seeing condition. So you're looking through atmosphere, and often when you're magnifying something this much, you get a little bit of wobbling, just like a penny in a swimming pool.
Yeah, in a grazing occultation, you can see the star flying along the edge of the moon in real time. I mean, if you zoom in on it, and you can definitely watch it moving in real time.
Right, or probably the moon zooming by the star.
But yeah,
This is wonderful. This is fantastic because not only you see the moon emerge, and then you see its shadow on Jupiter. This is just beautiful video. And the first time I did this, it was the moon occulting Saturn, and I had my friend's like 6-year-old daughter with me. It's just the 2 of us. I don't have very adventurous friends, but they have adventurous daughters.
this is the famous Jupiter rise image from Apollo, right?
Right. Okay. I'm looking for a spot to advance. Okay, and I need to go backwards. Sorry about that. So another thing that's really wonderful to watch in the sky, which is very easy to do anytime Jupiter is up, are the dance of the Galilean moons. So Jupiter has 4 major moons that can be seen even in a small telescope. They are, from left to right, Io, which is the innermost moon, Europa, Ganymede, and Callisto. And you'll notice actually their geology is very different. And that has a lot to do with their proximity to Jupiter, tidal forces, whether they're getting, for instance, the inner 2 moons have actually a lot of heat going on in them. So they don't have this rocky cratered surface quite as much. Io is volcanic. Anyway, it's nice to know that while you're watching these 4 little dots going around Jupiter, and they are endlessly entertaining. So one of the things besides the conjunction we were able to see was this moon here about to be occulted by Jupiter, about to actually in this case is disappearing behind Jupiter. The term for that is an ingress. And then when that happens, for every ingress, there's also an egress. So you can get timings for when these things are going to happen. And watch it go back both in and out. And the same things happen with the shadows of the moons too, often. So we had a rare triple shadow transit, and it looks like it was January 24th, 2015. This is a really well labeled photo where it shows both the moons superimposed on Jupiter, which we normally cannot see with a small telescope, and then their corresponding shadows. So for instance, Callisto is way down here, but Callisto's shadow is way over here. Europa is way over here, and its shadow is here. You can see it's much closer to Jupiter than Callisto is. And Eo's over here in this diagram, Eo's over here, and there's Eo's shadow. So the next picture is how it looked to us in a small telescope. There was only 25 minutes when all 3 shadows were on Jupiter. It's not unusual to see 1 shadow, 2 shadows sometimes, but 3 happening at the same time just doesn't happen very often. I happened to be outside. It was about 12:30 midnight, and the constable drove by, and I had her take a look, and she was delighted. This ended up paying off because 1 year later, I was photographing my house. I'm going to talk about lighting in April. And I was trying to photograph my full cutoff street light, my porch light. And it had just been in the next door social media, watch out for people photographing your house. They're probably going to rob it. So sure enough, I have my camera set up and the constable drives by. And I said, don't worry. I explained about the lighting. She said, I remember you. You're the one who showed me Jupiter last year. So you never know when you get a friend showing somebody an event like this. So I wanted to show you how you find out when these things happen. There are a number of websites. This one's called projectpluto.com, where you can get all the timings for these events. And I want to talk a little bit about the codes you need to know. First of all of these times are listed in universal time. So for instance, if you see 1:08, you've got to subtract 6 hours, and you're thinking about 7:08 p.m. as opposed to 1:08 a.m. for our time. I hope I got that right. The Roman numerals are the moons in order of distance from Jupiter. So if you see a Roman numeral 1, that's referring to Io, 2 is Europa, 3 is Ganymede, and 4, if that shows up, is Callisto. And then there's these little shorthands here. So SHA means it's a shadow that's going to start appearing across Jupiter. TRA means a transit. That means the moon itself is going to transit across Jupiter. And then you've got the shadow end. For every beginning, there's going to be an end also, and the transit end. There's eclipses, which I'm going to discuss later. That's actually, there can be two kinds of eclipses on Jupiter. You can actually have a moon passing the Jupiter shadow, if the geometry is right, or you can have, again, if the geometry is right, you can have one moon shadow passing over another moon. There's OCC, means an occultation. So that means that Jupiter is covering the moon and the moon's going behind Jupiter. So here's the geometry. When Jupiter is, when the sun is aligned with the plane of Jupiter's Jovian satellite orbits, and that's the sort of technical term. Don't say when are the Jupiter moon events, you need to know when the Jovian satellite events are, or the Galilean satellite events are. So satellite's a more technical term for moon. So this gives you an idea of the line of sight. This is how, say, an eclipse would work. And we have this moon is eclipsing that moon. In other words, it's not covering it up, but the shadow is landing on this other moon here. We happen to be in a rare period. Let's see if that's here. Oh, well, I'm going to show you one here. But this does not happen every day. It turns out that the ability to even see these only happens once every 6 years. And we're very fortunate because we're in one of those periods. The last time we had a series of eclipses and occultations where the moons passed directly in front of each other, or a shadow from one moon could cross over another moon, was in 2015. We are now in a period technically from January to November when these things are happening. But as far as the twilight, it's visible from March to November this year. So I found this Cambridge.org website, which has a whole list of these events, including occultations and eclipses. And it even tells you often the eclipse doesn't eliminate the moon, the shadow just dims the moon. So it even shows you how much dimming to expect. And so you can take a look at the dates and the times and Jupiter's availability to us in the sky at a site like skymaps.com to see if Jupiter is up. And then look at the times and see if they back up the 5 or 6 hours you need to, and see if they happen at nighttime for us. It has to be darkness for us to be able to see them. And pick some out for 2021 to look at. Now, a transit is when something small crosses over something big. And I also have like to watch those. So the more spectacular ones are the Venus transits, which I'm sad to say, unless you can make it to 2117, you've lost your chance in this particular lifetime. But it happened in 2004, June 8th, and also in 2012. And the cycles are odd. It can happen they're 12 and a half years apart, followed by 105 and a half years apart. And I'll show you why that is in this diagram. So first of all, for this to even be possible, Venus, which goes above and below the plane of, say, the Earth's orbit, has to be at a node. It's got to be where it's lined up with the sun from our point of view. On top of that, we have to be in that same line too. So this could happen here, and we could be way over here, and we're not going to see a transit. So a lot of things have to happen at the same time. And so in one lifetime, you may have two chances, and then there's like another 105 years to wait again. But I did want to show you a little bit what that looked like. Here's a wonderful view taken in hydrogen alpha filter, where you see the Venus, and you get an idea of how large it is. It's actually, it's a lot smaller than the sun, but it has some substance there. This is what we saw at the Darvaza gas crater in Turkmenistan. This is something called the Sunspotter, which is great for partial phases of eclipses and the Venus occultation here. And why did I go all the way to Turkmenistan when it was actually visible here in Texas? Well, because it was so cool to camp out at the Darvaza gas crater and then have this happen at dawn the next morning.
Yeah, it was easily visible naked eye. I mean, I was at a conference and one of the exhibitors was handing out glasses, dark, the eclipse glasses, and everybody could see Venus as a little black dot on the sun.
Yeah, I'm not surprised. Venus is big enough. Mercury, I'm not sure. I saw my first Mercury transit when they called some people from the Astronomical Society over to the Museum of Natural Science.
No, Mercury's too small, but Venus, even people whose vision wasn't that good could see that there's a little black dot on the sun.
Right. I'm not surprised. Mercury's quite a bit smaller, and it's easily visible again in a small telescope. So this is a multiple exposure of Mercury. This is the Mercury transit 2019, which I missed. I think the last one in Houston may have been a little bit cloudy, but I didn't do it. I know we were also called to the museum again at that time, but that's something, and I was surprised. We actually have to wait a long time again. It's not until 2032. So again, grab these things when you can. You may not have another chance for quite a while. However, in your lifetime, there's going to be something interesting happening at some point. I actually don't have a whole lot of slides about lunar eclipses. They're always beautiful when they're total because of the beautiful red color of the moon. Again, we have to be exactly lined up. Anytime there is a total eclipse of the sun, 6 months before or after, there's also going to be a total lunar eclipse somewhere on the Earth if it's nighttime for you. So actually, the next one here is on May 26th. And we'll be able to see the partial phases, but it's going to be another one of these pointy ones where it's beginning to lighten up, I think, by the time it's total. So we may or may not be able to see totality. There's this wonderful website called timeanddate.com, which is wonderful for transient events. If you do have an eclipse, you can plug in your city and state, and it'll even do animations exactly how you will see it from your city, and where the shadow is in relationship to the moon. I mean, how deep the moon goes into the Earth's shadow. All those things show up, and the exact times for your place. The other thing that's wonderful about timeanddate.com is I use it a lot for moonrise, moonset, and sunrise, sunset for planning. That's great for planning outreach events or your own observing, so that's wonderful, just to be able, and sometimes I find it not even by going to timeanddate.com, I just put Houston sunset, sunrise, and the timeanddate.com is the first site that comes up, and it's already on the sunrise, sunset tables for that month. So very easy to find. And of course, this is my favorite. One of the most spectacular phenomena in nature is a total eclipse of the sun. I just got this sent to me by our own Don Taylor. So what I like about a photograph like this is it's actually almost a little more detailed than you can see naked eye in the corona, but you do see a lot more detail with your eye than you see in most photographs. So you can see a lot of this brushiness. The other thing I like about it is that it is accurate that the sky is not black behind the total eclipse. It is a deep blue. It's more of a deep dusk. And you can only see the very brightest stars and planets. So I don't remember what was over here in 2017, but
Regulus was very
Regulus,
close to the sun.
right,
Yeah.
right. That's Regulus. And then if you have clouds, it's actually, you don't want any clouds in front of the sun, but actually there will be beautiful sunset colors all the way around you in a total eclipse. So I was going to spend a little bit of time with eclipses. The next one is actually in Antarctica, off the waters of Antarctica, but it's not too early to start planning for the one that's going to be in Texas in 2024. So I just want to talk a little bit about how those work. There are people who go all over the world. I'm one of them because I love the world travel as well as the eclipses. And these are some of them. This was in Kyrgyzstan. This is actually not an eclipse trip. This was that transit of Venus trip, but with the same group that chases eclipses. And so why go all over the world? Well, it's probably the closest thing you're going to see in nature to a miracle. So it's amazing to me, we have exactly one moon. We're not one of these, planets with 5 or 6 moons. And that one moon is 400 times smaller than the sun, but it's also 400 times closer. So its apparent size is very close to the sun. And so it can exactly cover it, but reveal the corona behind it. And when you see this, it really feels like you're looking at God when you see this real time. It's not just as stunningly beautiful, but it's like, how could we be so lucky to have this happen? So how often do eclipses happen, and why do they happen? Well, the moon's orbit is actually tilted a little bit to the Earth's orbit around the sun. So in order to have a total eclipse, it must be at one of these nodes where it's crossing from higher than the orbit than our orbit to lower than our orbit. And then we've got to be lined up with that also. So this shows you some of the possible eclipses. So, and how you can have also, so if you're, for instance, it's showing the whole orbit of the moon. So you've got to have, again, the moon, you've got to have the moon, Earth, and sun lined up this way. If you're lined up this way, you just get a normal new moon and full moon, and there's no shadow of the Earth on the moon, and there's no moon blocking out the sun. They're just missing the lineup. So there are different kinds of eclipses, and that's because there are different apparent sizes of the sun. So the Earth's orbit around the sun is elliptical. So sometimes the sun appears a little bit bigger, and sometimes when we're closer, and sometimes a little bit smaller when we're farther away. The same thing is true with the moon to actually a larger extent. Its orbit is also elliptical, so it's also sometimes farther away and sometimes closer. And this gives you a whole constellation of possible eclipses you can have, from up to a 7-minute total eclipse to an eclipse where the moon can't quite cover up the sun all the way because it's too small. So the ones where the moon is very small in comparison to the sun are called annular eclipses down here, named for the annulus of sunlight around the moon, which is also very beautiful. And if the moon's a little closer, the sun's a little farther away, and it's capable of covering up the sun, it can cover it up entirely. And for different lengths of time, again, depending on the relative size. So this is Joe Dellinger's, my favorite of all time, annular eclipse photos. And so it can be a very beautiful sight when you have a sunset one because of the colors of the clouds. This was taken in West Texas. This was one that you didn't have to travel across the world for. So the 2 of the annular eclipses I've seen have been relatively close by. One was in New Orleans and one was in my brother's front yard in Oklahoma City.
Yeah, and I'll just comment that that's completely unprocessed. I don't even own a copy of Photoshop. That's just the colors that came out and that's what it looked like.
And I imagine you didn't need a filter. Normally you would need a filter because that sun's too bright, but was that just the sunset?
It was just naturally one of those deep red ball sunsets anyway, so that you could look at the sun without the filter. And well, I didn't stare at the sun, but it was one of those ones where the sun was a red ball, and then the moon was in front of it too. And then that made it extra red because you're only seeing the light from the edge of the sun. So it was like a doubly red sunset. It was really bizarre experience.
Yeah, that must have been beautiful. Actually, one of the ones I saw was sunrise in Iceland. And we were practically the entire sky was overcast, but we went to the northern peninsulas of Iceland. And there was like this little tiny gap just above the horizon, and that's where we were able to see the annular eclipse.
That was similar. The sky was 95% cloudy.
Really? Okay, that was not clear. Anyway, it makes a gorgeous picture when you have that case. So really, in a way, you want some clouds during an eclipse, but it just makes you awfully nervous when they're there. But they actually make a more beautiful experience. So just to show you what the shadow of the moon looks like on the Earth, just like your own shadow, you've got a darker portion called the umbra, and you must be in this umbra, which is very narrow path to see a total eclipse. And then there's a much larger penumbra, and all these areas here get a partial eclipse. And this is what the shadow of the moon looks like from the space station. It's always fun to see those. They can see this racing. I think this was for the Turkey eclipse. The astronauts can literally see that shadow on the Earth. Now there's something called a hybrid eclipse, and that is one where the moon's and the sun's apparent size are so close that literally the curvature of the Earth, part of the Earth being closer to the moon, part of it being farther, makes a difference between whether you see a total eclipse, and that's going to be a relatively short eclipse. The longest it can be for hybrid is 1 minute and about 1 minute 30 seconds, 49 seconds, I think it is. And then if you're a little bit farther on the same path, the Earth's surface is a little farther away from the moon, and you get an annular eclipse. So why would you want to see a very short eclipse? In 2013, we went to Uganda, and what happens in most eclipses is you will get these prominences around the sun, but you'll get them in a long eclipse, you get them sequentially. So the moon's pretty big, and you see them on one side, and then as the moon progresses across the sun, some of the ones come out on the other side. With a very short eclipse, you get them all at once, all around. So this is a very quick handheld shot but with a digital SLR by Chris Treasel. The longest it was going to be on land was 23 seconds. And then we decided that the path there, where the president was going to be, it was only a 5-mile wild path. And the only road went across that path. We were afraid of, and it was partly cloudy. So we went to a portion of the road where you could drive along the road if it were clouded out. And we actually stopped with the family. And then 10 minutes before totality, sure enough, a big fluffy cloud started to sort of expand over the sun. So we hopped in and we went along this road. We were getting kind of close to the edge of the path. And then right at the 10-second point, we were beyond the cloud. We hopped out, saw totality. And this is this is what we saw. It's beautiful. And this is another reason to see more than one eclipse. The experiences are different. And of course, there were gorillas there, and it was just a wonderful cultural and animal trip also. Now, there are terms that you need to know if you do go to see an eclipse, because you need to know you will have data about when these things happen, and it helps you to plan where to be and when to be out, and what to expect when you're at an eclipse. So the terms you need to know are first contact, and you'll have a timing for that for your location, which is when the moon first makes the first bite out of the sun that the moon makes. Then you have the partial phases. Then you have something called second contact, and that's when when totality starts. So the moon's edge hits the opposite side of the sun. Third contact is when the sun starts the moon starts to move off of the sun, and you see the first bit of sun reemerge. And then you have the following partial phases. Partial eclipse, you just have partial, and that's it. So here's in kind of photographs how this looks, diagrams and photographs. So first contact, there's a little bit of a bite out of the sun, which is always very exciting when it's aimed exactly straight across. And you've been planning this for 2 years, and sure enough, it happens to the second when it's supposed to happen. Then you have the partial phases, and those are kind of fun, just like we were talking about seeing things move. If you are lucky enough to have sunspots, during the partial phases, it's fun to see the moon's approaching sunspots, because again, that's a great time to perceive motion of the moon across the sun. Then this is second contact, so it's just the last bit of sun disappearing. And this is third contact, when what we call the diamond ring reemerges on both sides. And that's the time to start using your safety glasses again. During totality, you do watch with the naked eye. So the next one that happens that's convenient to us is in Texas in 2024. I have a more detailed map here. It is worth, because of traffic, if you have the time, it's worth asking off for work early. This one's going to be on Monday, April 8th, 2024, in the afternoon, about 1:30 in the afternoon is totality. You don't want to be in Houston. No, a 99% eclipse is not good enough. And if you can certainly drive in there, but do expect a lot of traffic on the day of and afterwards. That often the traffic jams can be pretty horrible, although we have a very large path and a lot of roads into it. So if you have the luxury, I always recommended getting housing ahead of time at the center line. That means you don't, if you have all the amenities you need, you got food, you got bathrooms, you can observe an eclipse in comfort. And if you can arrange to have a vacation long enough and not have to leave until maybe a day or 2 days afterwards, you have an excellent experience. So I've started to discover that Airbnbs are an excellent option. It's a little nerve-wracking to rent an Airbnb 2 years ahead. I've done that twice and had it work out. The only thing in Chile, we had one, it was going to work out, but we had COVID-19. But our host actually sent us video. We probably would have missed it. People on the beach, it was a cloudy one in Chile this time. But it was just wonderful. Our hostess actually sent us a video an hour before saying it was cloudy and showing us the house we would have stayed in. And then afterwards, and she said she was aware that people at the beach did have a little bit of a break in the clouds, were able to see it. So we're thinking about doing that same vacation maybe at the end of this year with the vacation part that we were going to do, and maybe staying in her house, we hope. Now I have some fantasy things to show you. I first saw this at this is Bill Spitzeri's thing. This is what I call the ultimate conjunction. The Andromeda, if you are lucky enough to live another 4 billion years, and you're gonna have to find another star, because I don't think the sun will be, well, the Earth will certainly be inside the sun by then. You will be able to live through the Andromeda galaxies first crashing into the Milky Way, and then it's gonna rebound a few times. But it will be quite a sight to see this enormous galaxy coming at you. And even though it looks like these things are crashing into each other, it is expected that the stars are so far apart, you're unlikely to have a stellar collision. So we do know from spectral observations that the Andromeda galaxy is blue shifted, which indicates its light spectrum is shifted on the blue side. That indicates to us it's being compressed and that it's coming toward us. We're gravitationally connected. So it takes about 7 billion years or so for these things to stop rebounding and to form a giant elliptical galaxy.
Debbie, you got a date for that one?
As soon as things, there you go, as soon as thing stops. Yeah, about 4 billion years. I actually did not bring, there is another version of this where you get the Earth's eye view, although I think the Earth will not be around. And it's wonderful. I didn't want to take too long, but you can find these. I think that'd be so cool though, to be around when you got this galaxy coming. Now, this is what I call the ultimate transit, a black hole in front of a shock wave here. So the black hole's actually, this is gravitational lensing. It's actually distorting the light coming from behind it. And then I have one more. Let's see if I can get this advanced, what I call the ultimate eclipse. If you can get yourself behind Saturn and have it eclipse the sun, this is what Cassini saw. And let me go ahead and stop my share. And if there are any questions, I should tell you, I'm not a member of IOTA. I may not be able to answer extremely technical questions, but I have done all these different types of observations.
Hey, Debbie, we had a couple of questions. Joe Dellinger and Stephen Hyde asked essentially the same question about the equipment to use, I guess, based on some of your earlier slides when you were showing some of the video captures of the occultations.
Right. So I am not a videographer. What I can do is ask, I probably should have invited Richard Nugent, who used to be a member of our club, who has been doing video for quite some time of occultations, and I did them visually, but now they really prefer people with video to do that. So what I would recommend is going to the IOTA website. I believe they have all sorts of information, including equipment.
Yeah, I mean, I looked at that a while ago, and I mean, the camera they had, it required like 110-volt power, and I was just like, really? You can't do better than that? You know, something easier than that? Anyway.
I probably should have invited Richard to join us. I'll see if I can find that out. But right now, I think most people doing these things are using video because it's very, very precise. You don't have to worry about, we have to do things like estimate reaction time if we're just doing a verbal call on a tape.
Paul Maley basically told me he's not interested in visual observations anymore.
Right. I do know, however, that there have been times when I did something with Paul Maley and I was successful and his equipment failed. So, but as far as getting the data, I mean, you can certainly observe it for the phenomenon of it, but as far as data, I think they are now preferring the video equipment.
All right, and Antonio Oliva asked a question as well about Saturn. Antonio, do you want to come off mute and ask?
Oh, yeah, thanks. I was just wondering when you showed the Galilean moons of Jupiter and showing the Saturns and it transiting across Jupiter, can equivalent observations be done with the moons of Saturn?
No, because not usually, because normally we see Saturn's rings tilted. There's like 1 week. Saturn has a cycle of 13 years on one side, and I think about 15 years on the other side, where the rings open up, then they become edge on, and then they open up the other way. And I'm not sure during the edge on parts, the moons are much fainter. So I will have to look into that.
There's a period of like a few months, as I recall, where you can see Titan's shadow. And it's not as good as like the Jupiter ones, but I seem to recall I've seen it. And
yeah, I would think
it's like a few months every, 13 years or something like that.
20, yeah, 13 years on one side and 15 years. So there's, by the way, when Saturn's rings come completely edge on, there is 1 week where you cannot see them at all. And that's another thing. I meant to mention that as far as something that's changing in the sky. If you're doing this for a while, I definitely recommend looking at Saturn every time it comes up, and over time, you will see the ring plane change. So in 28 years, you will definitely see it come edge on and then go the other way. But yeah, there must be a time during that edge on portion where the moons are lined up with us. But normally, when you're looking at Saturn and the rings are very open, you will see the moons above and below it. And in a reasonable sized telescope, a small telescope with a dark sky, you can see up to about 5 moons. And even when it's not so dark, Titan almost always shows up.
The other weird thing that happens with Saturn is if the geometry is right, such that the rings are not quite edge on as seen from Earth, but they go edge on for the sun, you get to see the sunset on the rings. And that happened in 1994, as I recall. Anyway, it happened in the early 90s, and the conditions were nearly optimal, where we had the rings open several degrees and the sun set on them, and every night they were a different color. And they went basically from the normal color to sort of looking a little funny to like maroon to like dark brown to gone. Oh, and just night to night to night, they were a different color every night. And one night, I swear, they were maroon.
Wow.
But just one night.
Yeah, so these transient things, you got to catch them while you can. Skyandtelescope.com is also a good source of what's happening, say, this month. That's interesting. And usually once a year, they kind of give you the whole, they also often give you everything that's interesting that whole year.
All right, thank you.
All right, what other questions are there? Feel free to take yourself off mute and ask away.
Hey, Debbie, this is Bill Spizzeri. I don't know if this qualifies, but it kind of was a thing that you were able to watch change in the sky. I think it was about 1979 or 1980. There was a comet that cruised by, was so close, it was naked eye, and if you just stood outside for 10 minutes, you could see it move through the sky. Now, obviously, it's got to be really close to be moving that fast in your field of view, but it was interesting to see something changing in the sky for a while.
That was probably Iris Iraqi Alcock.
Yeah, that's it. Well, 79 or 80, something like that. Yeah, it had that weird name because it was discovered by a satellite, right? IRAS?
Yeah.
Right, and occasionally there are very close by asteroids, although they're often small, that if you know where that is, you would be able to perceive motion. For me, the comet experience, I went to Peru for observing, or actually, I guess we were in Chile during those observations, Comet Halley in 1986. And I was with the museum, and they gave me their 8-inch telescope to show inexperienced astronomers the sky for 2 hours. And then they went home, and I had that telescope to myself. So one night I saw Halley's nucleus was just sliding by a star, and they were very, very close together. And normally you don't perceive that motion. It's this wonderful thing of having two things very close together, and then you're able to perceive motion. It was awesome. I mean, I really saw the comet sliding through the sky, but I did need a telescope to see that. But there was no other night.
All these things are great, but isn't it great that the configuration of the constellation of Orion always stays the same for us, okay? It doesn't.
Except for Betelgeuse, right?
Right.
Yes. Thank you, Bill. Yeah, you would think, you would think all of our lives, and then Orion changes on us.
All right, what other questions do people have? Anybody? Okay, I'm going to share my screen here, Debbie, just really quickly. And there's actually something that's happening in the next couple of days. So I don't know if you all can see this. Do you see my screen okay? So
Yes.
on the morning of February 6th, we are actually going to have Saturn and Venus right before sunrise within about a half a degree of one another here. So you can see Venus here. The sun is, if I forward this another 2 minutes or so, you'll start to see the disk of the sun in this program start to rise above the horizon, but it's only about 6 degrees up in the sky. Venus is at that point, but you'll have Venus and Saturn very close to one another in the sky, and then Jupiter is down here, probably not visible because it might be a little too low. But if you have a nice view of the eastern horizon, this is something that you might be able to take a look at, or if you're in a high rise or something else like that. So 2021, even though we had the great conjunction at the end of 2020, 2021 seems to be the year of the conjunction, Debbie, from everything that I've seen as well.
Right.
So.
Yeah, I looked at that. I wasn't sure whether it was visible or too low. So thank you very much for mentioning it.
Absolutely. So something to look out for. And then another thing to look out for is our next general meeting, which is going to be tomorrow night. So if you haven't registered for that, please go to our website, astronomyhouston.org. There's a link to get registered on the Zoom system for that. And please join us then. We'll have our guest speaker, Dr. Aaron Clevenson, who will be talking about the Astronomical League and all the programs that we participate in there. So it's a wonderful organization, and the programs are absolutely fantastic. If you do the social media thing, we're on all the major platforms there, Facebook, Twitter, and Instagram. And if you have any questions, have anything you want to ask about the club, about tonight's meeting, anything at all, you can always send us an email at info@astronomyhouston.org, and we'll try to get that answered for you as soon as possible. So appreciate the talk, Debbie. Thank you very much. Like I said, 2021 is the year of the occultation, or the conjunction, I should say. So always go out and look up, and if the weather cooperates, we'll have plenty of these things to observe this year. So thanks for the talk, Debbie.